Right, thank you very much. So I'm going to do a whistle-stop tour of all the different types of tests and how we can actually use those tests and some of the unintended consequences of those tests. And as the databases grow in size and as more and more genealogical records become available online, genetic genealogy, the application of DNA testing to genealogical research, it actually becomes a really very powerful and transformative tool and is being used in ways that people perhaps didn't anticipate. So DNA testing kits have been available since the year 2000, but it's really only in the last 3 years that sales have taken off as the cost of the test starts to come down. And in 2017, more people tested in that year than in all the previous years combined. We now have a situation where probably over 30 million people around the world have taken a DNA test. Probably about 70% of those people are in America, but over 4 million people in the UK are estimated to have taken a DNA test. In the early years, we had a whole range of companies. Some of those companies have been and gone. A lot of the dodgier companies have now disappeared from the marketplace, and there's been a lot of consolidation. We now have, certainly for family history purposes, 5 main testing companies that we would normally use. And the market leader is now Ancestry DNA, and they have tested over 15 million people. And they are closely followed by 23andMe, who've tested over 10 million people. And then we've got some other players. There's Family Tree DNA, MyHeritage DNA, and a British company called Living DNA, who are trying to get into this space as well. So when you take a DNA test, if for family history purposes, there are actually 2 components to the test, though some of the companies also now offer a health report, but I'm just going to focus on the genetic genealogy applications. So you will get, first of all, you will get what is sometimes called an ethnicity estimate, although ethnicity is not really the right word, because ethnicity is something that is socially and culturally defined. It's nothing to do with your ancestry. But the companies have rather hijacked this term, and the correct scientific term is actually biogeographical ancestry. So this is a comparison with reference populations from around the world. But if you're a genealogist like me, then the most important part of the test is where you are matched with your genetic cousins from around the world. Now, I'll just give you an overview. I've tested at all the 5 different companies, and these are my percentages from all the different companies. And I'm not sure how much of that you can see, but they are all broadly in agreement that I am a Northwest European. But each company, they have their own reference populations they're comparing you to. They have their own methodologies for working out these percentages. You can only be matched to a population that's there. And they also cover different time frames. They are now trying to bring the time frame down more towards the present day rather than looking at ancestry from 1,000 or 2,000 years ago. But then you can see I've got major differences. So MyHeritage DNA, I come out at 9.2% Italian. At 23andMe, I get a 14.9%, I think it is, French and German. And some of the other companies, I am 100% British, or a very, very high percentage of British. And these percentages also change over time. So when Ancestry updated their algorithms, overnight I went from being 21% Great Britain to 94% England, Great Britain. So, and just this week at 23andMe, I added an extra 7% of British and Irish DNA when they updated their algorithms as well. But the companies are now focusing on the last couple of 100 years, and they can actually, what they're doing is putting people into genetic clusters, matching you with people who share DNA from the same region. And this part of the test is actually much more reliable. MyHeritage are trying to expand into this area as well. So when Ancestry there, you can probably just about see that they've assigned me to central and southern England, Devon and Somerset, Gloucestershire, Wiltshire. That part of the test is actually very, very reliable. And certainly if you have British or Irish ancestry, those results can be very meaningful. Even if you don't know anything about where you are from, you can actually get a very good idea from these results. So if you're Irish, there are about 100 regions within Ireland. They can pin you down to a very specific part, say, of County Kerry. But it's the cousin matching I want to focus on more. So we know from the biology we always get 50% of our DNA from each of our parents, and the DNA that we get from our parents is really a patchwork of the DNA from all of our ancestors. And when we go back a previous generation, we get an average 25% from each of our grandparents, but there's quite a wide variation around those averages. And then the DNA is diluted with each generation. And if you go back far enough, about 5 or 6 generations, you have some ancestors from whom you have inherited no DNA at all. But we can use this information about DNA inheritance to make inferences about relationships with other people. So if you were to take a DNA test, the company can match you with other people in the database, and if you share 50% of your DNA with someone, you know that it has to be a parent-child relationship or a full sibling relationship, and there are ways genetically of distinguishing between those two relationships. If you share 25% of your DNA, then you've got a wider range of relationships. You could be matching a grandparent, it could be an aunt or uncle, a niece and nephew relationship, or it could be a half-sibling relationship. And then as the amount of DNA shared starts to decrease, the number of possible relationships starts to increase. So with DNA evidence, you always need the context, someone's age or a location, and you also need the family history research in order to be able to work out exactly how you are related to other people in the database. So this is my match page at Ancestry DNA. I've tested both of my parents, and fortunately, they both came back as my biological parents. And then my next highest match is somebody who's predicted to be a second cousin, but you can see that they actually predict it somewhere between the range of second to third cousin there. And then I've got something like 30,000 matches. I can keep scrolling down and down the page, and here you can see I've got people who are predicted to be third to fourth cousins, and then it goes on to fourth to sixth cousins and so on, fifth to eighth cousins. So as a genealogist, a test like this is actually really, really helpful for me. Not only can it confirm that the research I'm doing is correct, but also it's a way that I can scientifically test hypotheses about relationships. So is it, for example, if you've got a cousin and you're not sure if they're your full first cousin or your half first cousin, you can use a test like this to try and work out what the relationship is. But DNA testing is also really helpful for people who know nothing about their ancestry. So if someone is a foundling, if someone is donor conceived, or if someone is adopted and they don't have access to adoption records, they can now take a DNA test and they have a good chance of being able to identify their birth parent or birth parents. And we've had a number of high-profile cases in the UK where people have had success. Anthea Ring was able to identify both of her birth parents through DNA testing. Gary Gatwick, a bandit at Gatwick Airport, was again able to identify his parents. And people who are donor conceived are able to identify their sperm donors. And sometimes one reunion, this lady in Ireland was able to find her birth mother, and she was 103 years old. So there's always hope for everyone in these cases. But the other side of the coin is that DNA testing is delivering lots of surprises. And the market has now expanded. It's not just genealogists like me taking the DNA test. There's advertising on TV. People are being given DNA tests as Christmas presents and as birthday presents. And some people are getting big surprises when they test. So one of the common things is that somebody discovers that their father is not their biological father. Or people discover that they have siblings that they knew nothing about, or sometimes that they have children that they knew nothing about. That holiday romance on a Greek island 30 years ago, suddenly there's a child that appears on the scene that you didn't know existed. And with donor conception, of course, this raises issues because the donors were promised anonymity. And we're also starting to hear a lot of horror stories where the fertility doctor, rather than using his own sperm, rather than using the father's sperm, substituted his own sperm. And we are actually seeing some very large families now as a result of some of these cases. The largest number of siblings identified in one genetic family is 189. So there are now people who are going to take a DNA test who will discover not only that they were donor conceived, but they also will suddenly find that they're part of a huge family of 150 or more half-siblings. And we're also getting other surprises from DNA testing. These two ladies, aged 72 years, took a DNA test, and they discovered that they were switched at birth in the hospital. They were both the mothers took home the wrong babies, and they were both brought up with the wrong parents. So with all these surprise results, some of the companies now actually specially train their customer service reps to deal with the customers, because of course the first thing, if people get strange results, they ring up the company and say, well, you've made a mistake with my test, but that's usually not the case. And there are also lots of support groups that are being set up, all on a very much informal basis. So there are quite a lot of groups on Facebook. There's one called the DNA NPE Gateway. NPE now stands for Not the Parent Expected. And they will actually assign people to subgroups depending on the nature of your NPE discovery, whether you're a foundling or a donor conceived, or and there's also support groups if, say, it's your partner who's had a surprise discovery, because these findings actually impact not just the person who's taken the test, but also the wider family as well. And there are some people in America who are genetic counselors who can provide support and advice. But this is really a new area, and I think there is a greater need for a lot of support for people facing these scenarios. And the other area where DNA testing is now being used is to solve crimes. And this all came to our attention in April last year, and there were two cases that that appeared in the media reports within about 2 weeks of each other. The first is the case of Buckskin Girl, and she was a murder victim, and it transpired that her DNA had been uploaded to a genealogy database, and she'd been identified through a first cousin once removed who was in that database. And the second case is probably a much more high-profile case, the Golden State Killer, who was responsible for about 50 or so rapes and a number of murders in California from about 30 years ago. And he was also identified through a genealogy database, not because he was in the database, but because he'd got third and fourth cousins who were in that database. And it was exactly the same techniques that are used to try and identify if someone's adopted or a foundling, the same techniques of trying to match someone through their cousins, doing the family tree research. If you have a match with a second cousin, that means that you must share one set of great-grandparents in common. And it's then just a straightforward matter to try and trace the family tree forwards, trying to find candidates who are in the right place at the right time. But the site that was used to solve these cases was not one of the commercial testing companies. It's another company called GEDmatch. And they're really more like a citizen science website set up by two genealogists, and it was really to help adoptees and provide tools for them for their unknown parentage cases. So if you've tested at Ancestry DNA and you want to compare your results with a cousin who's tested at 23andMe, rather than paying for another test, you can both upload your results here and compare results. And they've also got all sorts of other tools. It's a very primitive-looking website to people who don't know what it is. But it's actually got some very, very powerful tools. And at the time when these kits were uploaded to the database, the site policy didn't specifically stop law enforcement using the database, but it didn't specifically allow it either. The site has now gone through a number of changes in the policy, and they've now decided from May they removed all law enforcement access, and they've asked people to opt in again. So when these cases were solved, there were 1.2 million people in the database. Now there's a separate law enforcement matching, and so far only 10% of the people in the database have opted back into law enforcement matching. And then after this discovery of GEDmatch being used for criminal cases, we then, and in January this year, one of the commercial companies, Family Tree DNA, suddenly announced that they were allowing law enforcement to use their database for matching purposes. And then they started to do they're one of the only company that actually has their own laboratory, and they have now started to do forensic testing for law enforcement in the US. They only allow, at the moment, US law enforcement agencies to use their database and under specifically controlled conditions. And we've now got a variety of companies who are offering these services. So Paraben have been at the forefront of a lot of these cases. I reckon there are now probably over 100 cold cases and missing person cases that have been solved in America using genetic genealogy databases. Paraben have solved around about 70 of those cases. There's also something called the DNA Doe Project, which is a volunteer project, a not-for-profit organisation, and the people volunteer their time to build the family trees to try and identify the missing people from their DNA. And since then, we've had a whole load of other companies who've tried to get in on the action. So there's Bodhi in America, and there's another whole load of companies now. Some of these are people who started off as volunteers on the DNA Doe project, and they've now decided to set up on their own. But there are still all sorts of ethical and regulatory issues that are unresolved. And I actually wrote a paper for Forensic Science International looking at some of these issues. And one of the big things is that it's the question of consent. You may not have taken a DNA test yourself, but it may be that your third cousin has taken a DNA test. That means that part of your DNA is in one of these databases. So it may be that you get the FBI ringing you up to help with an inquiry because your third cousin in America is in one of these databases. Who decides when these databases are used and how they are to be used? And that's something that still has yet to be worked out. There's all sorts of things going on behind the scenes, people trying to develop policies. But at the moment, it's really like a sort of live experiment, and the rules seem to keep changing as we go along. So I'll just end with one quote from Sir William Blackstone, a famous lawyer from the 18th century, who said, "It is better that 10 guilty persons escape than that one innocent suffer." And I think it's a question of getting the balance right, because we've got people on one side who are victims of crime and the police who are desperate to use any new tools that are out there. But you've also got the other side of the coin. You need to make sure that these tools are not used in the wrong way and that innocent people don't suffer because DNA evidence is not being interpreted in the right way. And it is possible, even if you've never been at a crime scene, your DNA could be found at a crime scene. So DNA evidence should never be used on its own. It always has to be used in combination with other evidence. Okay, so I will end there.
Thank you very much, Sara. So, yes, I'm going to try and give us an overview to get going of human ancestry and essentially how it works, what it is, just to raise maybe some issues that might come up, might be relevant to things we discuss later on. Certainly things that are very fundamental to the work that I do in human evolution in Cambridge. And ancestry, I should say at the start, is a difficult topic to talk about, primarily because the language is a bit of a minefield. You can probably see that when I get going, and I'll try and be careful and point out on a couple of occasions where we have to think a little bit carefully about how we talk about what we mean. So the natural place to start, I think, with ancestry is family tree. This is your family tree, essentially the same as my family tree, and indeed everybody's. This obviously shows only the first, most recent 4 or 5 generations, I think. You can obviously extend it as far back as you want, each time doubling the number of ancestors that you have. I think most people have a fairly intuitive sense of how ancestry works in this way, or genealogical ancestry. Although it's true that some people forget when talking about, say, their distinguished ancestor 5 generations back, that that's one of 32 individuals who are equally related to about distance and time, and certainly in a genetic sense, are about as relevant. And that's the other aspect of this, which is that it gives us a sense of how genetic ancestry works. You get half of your DNA from your mother and half copied from your father, and they in turn copy half of their genomes from their parents, and so you, on average, get a quarter from each of your grandparents, on average, an eighth from each of your great-grandparents, and so on. And I say copied. Strictly speaking, the copying is not quite exact. There's a very, very low error rate, such that every child differs from their parents to about 70 or 80 positions in their whole genome. Now, the whole genome is about 3 billion base pairs in length, so that's an extremely low rate of error, but it is important. That's the source of all the genetic variation between individuals all around the world. So let's focus on an example which might be relevant for genetic testing, where there's an individual, say you, and you might have a great-grandmother who is from another part of the world, let's say China, and none of your other ancestors using this bit of your tree are from another part of the world. So it's a remarkable thing, and you might not know about this because it's not unusual for people saying to have been adopted, or their mother or grandfather or grandparent to have been adopted. You might not be aware of this ancestry. And we sort of are complacent now and we take it for granted, but I think it is quite remarkable that just by knowing your genome, just by looking at your DNA, without knowing anything else about any of these ancestors, let alone what their own genomes are, we can detect this ancestry and identify it and the part of the world that it might come from. And in essence, that's because there are patterns of DNA that vary, some are more common in some parts of the world than others. And it's these patterns that we identify, say, in an eighth of your genome in this case. So to understand why that and how that arises, we need to look at, I think, a bigger picture, a longer time scale. So I'm going to try and give you a sketch. I'm going to try and, maybe a opportunity more appropriate way to describe it, of all of human evolution of the last 500,000 years. And I'm going to do this by splitting the screen in half. On the left-hand side are things going to be going on in Africa, and then the rest of the world on the right-hand side. And we're starting at the top, 500,000 years ago, and we'll work our way down to the present day today. So at that point in time, all our human ancestors were in Africa. And we know this primarily because the fossils and genetic data from the present day doesn't really tell us all that much about things this far back in time. But a couple hundred thousand years later, time scale right, we do see the first fossils that look like us. They're sort of fossils that we tentatively identify as Homo sapiens. Still, we don't say very much about this from genetic data, but I'm kind of illustrating here with these blobs that there's a sense of inheritance that this population earlier in time has descendants in the one later, and there's a stick joining. Because obviously we know that real populations, real human societies are continuous in time and space, and so it's a very crude representation. And then over the next couple of hundreds of thousands of years, we can start to detect in the genetic data evidence for multiple populations within Africa, some structure. There may have been structure earlier on, but we don't detect it, and we start to see it around about that time. And then a particularly important event, 50 to 100,000 years, is the emergence of Homo sapiens from Africa out into the rest of the world. Quite a rapid expansion into the Middle East and then into Europe and across into Asia, reaching Australia by about 50,000 years. And in the last 50,000 years, we have this global expansion all around the rest of the world, both in Africa and elsewhere. Now, it looks like there's a lot more structure and things going on. Most recently, that's probably primarily because, like I said, that's the bit that we can see most clearly. We can tease out and distinguish between structures at that point in time. Earlier on, things are a lot more vague. But it's plausible that populations and people really were more mobile back then. And we can see that there's lots of mixing, and it's not just a simple tree. There's populations that are taking components from multiple earlier populations. For example, Europe here we have, so here's Europe, we have European ancestry, and I say that advisedly. European ancestry in this sense, on this scale, is a mixture of, roughly speaking, 3 components: an earlier one from the out of Africa event expansion, and then later on one from the Middle East and from the Near East associated with farming, spread farming, and then another wave from Central Asia. So there's these three mixtures making up European ancestry. And that's European in the sense, there are of course many people living in Europe who are European, culturally, politically, who might, maybe their parents arrived recently from another part of the world. This comes back to this question of language that I was talking about. So we have this sense of European ancestry being something which is described in this way. And the picture there is quite similar. You could tell a similar story all around the rest of the world. We probably know a little bit more about things outside Africa, partly because we can get fossil DNA from individuals going back about 50,000 years, whereas in Africa we have yet to be able to do that. The DNA doesn't preserve as well in the African climate. Now, that's essentially all we need to know, unless it's sufficient for our purposes here to explain why genetic ancestry can be identified in different parts of the world. But there is one bit I will add, a bit of the puzzle, which is that humans, or Homo sapiens, not the first humans to emerge from Africa, because obviously there were early ones, and I think everyone's familiar with Neanderthals. There's also this other group called the Denisovans. We know even less about those. We know them from fossils, and we've been able to get a little bit of DNA, sufficient to get their entire genome sequence. And so for both Neanderthals and Denisovans, we can detect that there was, in fact, I've sketched it in just with kind of dotted lines, a very small amount of ancestry coming into non-Africans through inbreeding between those two populations when they met, and that's present now. That ancestry is in all non-Africans today as a result. Anyway, that's the kind of picture that we're working with. So, come back to the question that I posed, which is how can we tell that, say, some DNA or some patterns of DNA are specific to one part of the world? Well, I mentioned that there are all the time, every generation, arising new variants, new versions of DNA. And if we suppose, let's consider one, there's a star that I've drawn up here. Let's suppose a new, we can call it a mutation, a variant, there's all kinds of words. Suppose we're looking at one that arises a long time ago, 300,000 years ago in Africa. Assuming that's passed on to that individual's offspring and then transmitted to subsequent descendants and later generations, we might reasonably expect then to find that in all of the populations all around the world descended from that early African population. Now, in fact, it might not be literally everywhere because sometimes things can not be transmitted. And so, for example, here I've shown that there's some parts of Africa that don't have it, and maybe it didn't get into America either. But by and large, a mutation that's very old like this will have global dispersion today. We'll find it in lots of people all around the world. And vice versa. If we find it in lots of people all around the world, we might assume it's an old mutation. By contrast, if there's something more recently, and I mean that relatively recently, because we're still talking about, say, 20,000 years ago in some part of Asia, that might now only be found or only be common, say, in Asia, in China, East Asia, and perhaps in America. And that mutation we might not expect to find in an individual in Europe unless they had a recent ancestor from Asia, hence our ability to detect. In fact, if we found an individual with a lot of variants like this in their genome, perhaps making up 1/8 of their genome as a whole, that's how we infer that they have had some ancestry from an individual from that part of the world. So that's essentially the context that I want to give, and I just want to close with one caveat to that, because I think scientists will always give caveats to anything they say, and there's a very important one here, which is that it's a little bit misleading to identify a mutation or a variant like this, or a pattern, specifically with, say, Chinese ancestry, because I'm talking about something that occurred a long time ago still, 20,000 years ago, that could conceivably have come down to you through a different route, perhaps into northern India, perhaps you have a distant Indian ancestor, which then means that you find that particular pattern in your DNA that way. And so when we're talking about a small piece of ancestry like that, it's very misleading to say that just because it's found today most commonly in, say, Chinese people, or wherever in the world it happens to be, that this represents that ancestry. It doesn't. What it represents is similarity with those individuals, but the ancestry could actually be quite different and from different roots, maybe much more complex than I've drawn here. So that's something to bear in mind, along with the issues of language and how we talk about these things. And I'm sure we'll get onto more complex questions later on. I will stop there for now. Thank you.
Thank you both. Well, that was a fantastic half an hour to cover 500,000 years. That's pretty impressive. So I'm sure the audience is absolutely buzzing with issues that it threw up for them, but I think there are lots of possible topics that we can dig into. For me, they may include health, identity, privacy, equity, surveillance. So not much to cover in the next 50 minutes. So we'll spend about the next 20 minutes, just the three of us, and then you get your turn. Now, we don't have a health expert on the panel, but we said that we would do just a bit about the health issue, because that's not in either of your talks, but it is a significant part of why some people go and get their DNA tested. So if we do just the swiftest kind of 101, and I know Debbie, you as well as showing us all your, are you part Wiltshire? You have had a health risk profile as well done. Did you want to sort of mention that?
Yes, so I've tested at 23andMe, and I've also taken the new health test at MyHeritage DNA. I tested very early on at 23andMe, so I didn't get all the reports, and in fact I've just retested when they did an update, and my reports have just come through tonight, but I can't access them because it's all on my phone. The results that I had at MyHeritage threw up the surprising finding that I have one of the markers for Alzheimer's disease. But I thought so one of the questions is whether or not we as members of the public should actually have access to those results and whether or not we can interpret them properly. But it's not something that I'm worried about. The way that the results are presented, it seems to show that I've got a 70% chance of not actually developing the condition. And I can see from my family history that I have, both my parents are in their 90s and have got no sign of Alzheimer's disease. I have 4 grandparents, none of whom developed Alzheimer's disease, and 3 of them all lived to a great age. The only one who died young was because he smoked and drank a lot. So it's not something that I'm worried about, but I think one of the concerns is that you will end up with the worried well going to their doctors because they get these results, which is going to place an undue burden on the health service. Although I've not seen any evidence of that actually happening. But
the report that you signed up for, did it come with any opportunity to have genetic counselling around the results that you might get?
No, it didn't. If you were in America, you have to order the MyHeritage test through a doctor. But anywhere else in the world, you can just order it direct to the consumer. Mm-hmm. And 23andMe, that is also direct to the consumer.
When you said you were... Sorry, Aylwyn. I've written down ale, scale, ale, Aylwyn. You said you were going to talk a little bit about... because health is interesting because it gets us into the whole how much is genes and how much is environment. Mm-hmm. So, really what can we tell from a genetic risk score?
About an individual, often not all that much. The big picture is that our genomes affect nearly every aspect of us in some way, and there is a genetic effect on all kinds of traits or characteristics. Sometimes that's a very minor effect. In rare cases, it's a large effect. And that's one part of the picture, because then, as well as the genetic factors that may increase your propensity slightly for one way or the other for a given characteristic, which may be a disease, or it may be some other aspect of you, like your height or your aspect of your personality. Lots of very complicated things. As well as these genetic effects, then the environment, which includes not just things like your diet, but also the society that you're living in, your upbringing, all kinds of things, everything essentially that isn't genetic. That can also have a huge effect. Sometimes it's a much bigger effect. So the net result of that is that for any one individual, just looking at their genome, it's very unlikely that we can just look at them and be very confident about things, even things like sort of
eye color and things like this, which people have talked about as being a thing that you can tell, actually the accuracy of that isn't all that great. So one has to be quite careful about things like that. There are some parts of the genome where there are certain variants. If you have them, you're guaranteed to have that particular condition, say. And we know about, and the most obvious example of these are certain kind of diseases which are passed on without fail. If your parent has the disease, then you will have the disease. Those things turned out to be extremely rare.
So that would be something like Huntington's?
For example, yeah. And there's a good reason why those things are rare, because the particular genetic variant that causes them is obviously not very beneficial. And so the likelihood of it being passed on over and over again is actually relatively small, and therefore natural selection tends to reduce the frequency in the population. And so most of these things, as a result, most of those things are not relevant to most people.
So just to get back into kind of your core value, both of you, I think one connection between, so one of the things I wrote down as you were both talking that connects together kind of health and forensics and genealogy and deep time and history and geography, is the power of the corpus. So you both said at one time or another, you mentioned something about what's in the database, and I'd like you both to talk to that. So I think I added together some of the figures that you put up, Debbie, and it looked to me like 25 million people were in a couple of the key databases you talked about, and we were talking in the hall, Aylwyn, about the enormous scarcity of ancient human remains. So our predictive power about anything is only as good as how much stuff we have inside the database. So maybe, Debbie, you can kick off. And what's in there? 25 million sounds like a lot if you're just looking at the UK. But if you're making assertions about the UK and the rest of the globe, it's really very little. And it presumably has baked-in bias.
Yes, there are very big biases in the databases. So if you are European, if you're American, if you're British or Irish, you're going to get a lot out of one of these tests. If you are Asian or African, you will get very disappointing results. So I saw some results for somebody who was from Ghana. All his parents are from Ghana. And one of the companies assigned him to 85% Nigeria. And when I looked at the reference populations for the company, it turned out that they didn't actually have any reference populations for Ghana at all. So they're just matching him to the nearest other population. But in theory, you should be able to get the very granular detail that we're starting to get within the British Isles for other countries if you have the populations. But in India, for example, a population of 1 billion people, Ancestry have fewer than 100 people in their reference population.
Because there's equity issues in here as well, because it's you've got to be able to afford to have. It's a private thing at the moment in most places. So the overrepresentation is of people who can afford. It's a kind of a luxury.
Well, it's both things, because also the reference populations are drawn from research samples, and you've got those same biases in the research. So it's coming down slowly, but still overwhelmingly most of the research is focused on people in Europe and in North America.
So then we get into potential kind of exploitative situations. So if somebody approaches a bunch of people who are Irish and says, we can help you with genealogy tracing in the UK, if you're from an Irish background, they might actually have some success. But if, as is happening in the US, you approach the African-American diaspora who have a kind of a hankering for roots tracing owing to historical injustices, what they might get out of the database could be frankly rubbish, because that's not necessarily a well-represented population inside the personal.
There are quite a lot of African Americans in the database. What there aren't in the databases are people from Africa. So the African Americans would dearly love to have people from Africa that they can match to, because that would be, if they have enslaved ancestors and they don't know where they're from, actually having tangible evidence of a genetic connection in a country in Africa would be a wonderful find for them. But then you've got the danger of exploiting the people in Africa if you then start going out taking samples from Africa to help rich African Americans who want to know their origins. And it's the same with, say, Native Americans, where a lot of Americans want to take a DNA test to see how much Native American ancestry they want, but that's not going to help the Native Americans to do the type of research that they want to do, which is very different. They have very different focuses from us.
And then, Aylwyn, do you want to talk of the road accident where all of these kind of cultural hankerings start to hit what's available in terms of deep time, and there we have a kind of bit of a mess of a lot of nonsense being talked.
I mean, to some extent it was evident in one of the pictures I showed in that when it came to what was going on in Africa, we know a lot less, and that's partly because we have so much less DNA sequence and genetic research that's been done in Africa and in Africans. But it's not just Africa. There are other parts of the world that are equally unstudied. It's not just people who, like me, who want to know about human evolution that affects. That does also affect our more general, our understanding of human genetics in different populations around the world, and the extent to which that impinges on healthcare. It is also a major disparity. So a lot of our understanding about the genetics of medical genetics and genetics of disease is based on studies in Europeans, which may not be all that relevant in Africa, partly because the genetics is different, partly because the environmental factors and their interactions with the genetics are different. So really what we need are genetic research done in Africa by African people involving African participants, and for it to be done in that way, in a really fair and equitable way. That's really what we need to do. And there are moves afoot now to start doing that, but it's a slow process. It will take a while.
Debbie, you touched on the kind of perniciousness of the sloppy use of language with the kind of ethnicity score, and that slide where you talked about kind of 10% Wiltshire and 5% Lewisham or whatever it was. Kind of made me feel a bit uncomfortable, having only 2 weeks ago seen another presentation that talked about there is much more genetic variation within sub-Saharan Africa than in any of the rest of the world. And I'm struggling to fit those two things together. So what should the ethnicity scores be called? If we ruled the world, what would you rename them?
Well, some of the companies offer better terms. Some of them call them ancestry composition, my origins, and ancestry painting, I think it's called at Living DNA. And so three of the 5 companies actually avoid the use of the word ethnicity. But there's also the complication of using political terms, country terms, to represent something that is actually it's not about present-day genetics, because this is representing your ancestry going back for, say, 500 or 1,000 years. So Germany was not a political entity; it was not an entity all those years ago, and so many other countries were also very, very different. So, but then one of the companies did actually try and use different words at one point and just came up with vague geographical terms, and the customers all complained, so they had to revert to using all the political names. So I think it's a mixture. There's a lot of expectations from the customers. People want to have their percentages from different countries, but it's not necessarily telling people what they think what
and
people
I think in the
means.
world we're living in today, that has potentially the possibility of kind of reifying existing misconceptions and biases and divisions. It's a risky business. There's no other nice way of me putting it. When I see a slide that talks about your 10% Wiltshire, part of me thinks that's got to be nonsense. The corpus just isn't big enough. Does it? If we relabeled it biogeographical scores and we relabeled it, I don't know, would it be... Is it nonsense?
Depends a little bit on what exactly they're doing, which I'm not certain about. In some cases, these are proprietary things that they won't tell us the details of. So you can, for example, there have been studies where if you can actually go down quite fine resolution if you start to say, look only at people who all their 4 grandparents lived in a particular place in a very small localized part of the world. So it turns out actually there are more of those people than you think. Quite a lot of people have all their grandparents within 100 miles of each other. And if you sort of exclude all of the people who have much more diverse recent ancestry than that, then you can actually you can narrow down particular combinations of patterns of DNA really on a quite fine scale. Now, whether or not you can get something like a smaller, say, Wiltshire, I'm not certain, or Lewisham, even less so. but it is surprising, given that caveat, how much genetic data does tell us about patterns of movements of people and populations and geographical ancestry in the relatively recent past, last several hundred generations. The problem is that, of course, we know that there has been all of this movement and large-scale movement, particularly around about, say, in the Bronze Age and a few thousand years ago. It seems like there were large changes in ancestry in Europe and also in Asia. So that probably wipes a lot of the slate, or at least rubs out a lot of this kind of structure locally on that longer time scale. So it depends how far back you want to go. I don't think anyone whose ancestors necessarily were all in Wiltshire a few hundred years ago could say the same thing about a few thousand years ago. So there's always a time scale that you're talking about.
Mm-hmm. Now, I'm aware that as DNA has entered the fray, there are many disciplines whose noses are out of joint. Historians, archaeologists, paleontologists, genealogists. Do you want to talk a bit about how has some of this information upended previous views of on a historical timescale and on an evolutionary timescale? So how is it rethinking our sense of self?
Do you mean things like ancestry testing more recently, or more generally the kind of studies that we've done?
You can answer it.
Because I mean,
like. Go full David Cameron.
Pretty much,
just answer the question.
Pretty much everything we have discovered has turned out to be a surprise in one sense or other, and that's partly how science works, because people sort of deliberately fixate on things that they know are not really quite true. But so it was quite a surprise, for example, that there was Neanderthal ancestry in all modern humans. That's a big one, that going back 10 years ago. People have been very surprised to find that there has been a lot more genetic exchange, movements of ancestry between populations on the 1,000-year timescale that I talked previously, and still presently. I think a lot of archaeologists did not expect that to be the case, and they actually were a little bit concerned when there was a sort of, it seemed initially like a kind of revival of older ideas about, invading hordes and people like that. So there's a bit of miscommunication about what all this means. Doesn't necessarily mean that there was an invasion or a migration with wagons and everything. It can be a much more gradual process where people are just gradually, ancestry from one region is coming into another over a longer period of time. On the other hand, it does look like sometimes there were quite sudden changes in our ancestry. So I think what we're seeing, which is a surprise to us as scientists in that field, is a much more mixed up picture, a much more complex picture than we had previously expected, both in Europe and elsewhere around the world. Mm-hmm. Just going back, in a relatively short space of time.
And then on the more kind of
in the historical time frame, I would say that DNA testing has actually been a transformative tool because it enables us to answer questions that we couldn't previously have answered. So Richard III is a good example where DNA testing was used in combination with other evidence to actually identify the remains that were found in the car park at Leicester. And things like World War I and World War II soldiers where human remains are found. DNA is now a way of actually identifying those people and bringing closure to the families. There's a historical case in Ireland where in a place called Tuam in County Galway, where there were about 800 babies found in a mother and baby home, and the death rate was unusually high, and all these children were buried in what turned out to be like a sewage pit. So DNA testing is now going to be able is now a way where it can be used in that situation to identify those children and again to bring closure to the families, because some of them just don't know if they're sibling was shipped off to America, or if they actually died or not. So, I do think that sometimes the tools aren't deployed as well as they could be. So now we've got all this more advanced testing that could be done with some of the results I showed today. But in many cases, the scientists are still just using Y chromosome DNA and mitochondrial DNA for these questions.
Do you want to unpack that a bit?
So, okay, yes. Sorry, so Y chromosome DNA is inherited by a father, passed on to all his male children. So it just follows the all-male line. Mitochondrial DNA is passed on by a mother to all her children, but it dead ends with the sons. It doesn't get passed on. So that follows the all-female line. So that covers two outer branches of your family tree, but it doesn't cover all the other branches in between, which are covered with these autosomal DNA tests, which I've spoken about tonight, which could be used much more effectively in some of these historical studies than they have been in the past.
So just so that we understand, the majority of the kind of market leaders are doing
autosomal DNA.
Okay. And these more unusual kinds are offered by sort of a few specialist outfits, or
well,
only
it's
in
family
research
tree
labs?
DNA. That was the original tests that were available in the year 2000. But because they only cover a limited part of your family tree, they are not so popular as the tests that cover all of your ancestors.
And in a research setting, you use all of them?
You use as much as you can get, and so sometimes there are reasons why it's quite difficult, particularly if you're looking at ancient DNA from a fossil. It can sometimes be difficult to get DNA from the whole genome, and so you end up just looking at just this one part, the mitochondria often, because it's easier to get sufficient quantity. So there might be reasons like that, but ideally, yes, the whole genome tells you much more. The whole genome is essentially millions of times more informative about some of the questions that you might want. It all depends on what question you're interested in.
You've provided me with a fantastic segue into, let's see how we... okay, this will be my last question, and then it's the audience's turn. So you talked about whole genome sequencing, which leads us into a sort of potential dark side. So if the history of science tells us one thing, it's that we invent or discover something beautiful, and then pretty quickly it becomes something horrible. Evolutionary theory begat eugenics, atomic physics begat Hiroshima and Nagasaki. So whole genome sequencing, really exciting, tell us all sorts of stuff. But what happens if it's in the hands of governments? And then we're into the realm of potentially genetic surveillance. Now, there are at least 3 governments we can name who are buying up sequencing machines and positioning themselves for sequencing their entire population's genomes. So I don't want to bring us down, but me personally, I find that alarming. Now, Debbie, you're the enthusiast for all of this. So do you find that alarming, or do you think that we can head it off, or what's your view?
I think it needs to be controlled responsibly, because big data can be really powerful. We're not going to solve all these problems with health or, put criminals away unless you have big databases and you use them responsibly. So I think it's a question of having correct governance in place to make sure that the tools aren't misused rather than not using the tools, and also giving people the power to have access to their own data, and the people who are using the data need to be transparent about how they're using it, and they need to be held to account about how they're using it, and they also need to use properly validated methods whenever they are using it for whatever their purpose they're using it for.
So let's try to head off a Cambridge Analytica moment with DNA. Let's not be zooked when it comes to DNA. And what's your feeling?
Yeah, so I think people should be concerned about governments collecting large amounts of data, or other actors, bad actors collecting large amounts of data. Not particularly because it's genetic data, though, actually. I think that genetic data, for the reasons I've sort of alluded to, is not as informative about you as people imagine, and that there are other forms of data, things that you eat, what you look like, all kinds of things about you, which are much more informative about many important aspects of your life and your prospects, and which people, for some reason, are perhaps less kind of concerned about. So I think we should be we should be thinking about data in general about us as individuals as something we need to think about. Genetic data is one part of that. It's not necessarily the most important at all in terms of telling things specifically about you. That would be my
So I should be
feeling
more concerned about some kind of unholy mashup between my Ocado history and the face scan I have to put into Airbnb.
Exactly.
Right,
And
okay.
if you're doing that for a bit of free Wi-Fi, then that's probably something you should think about more carefully.
Right, that's enough of us. It's your turn. There are usually a couple of roving mics. Where are our roving mics? And if we raise a few hands, and what I'll do is I'll line up maybe 3 questions, and we'll take them, and then we'll come back to the audience for another 3. Okay, so that's our first 3.
Hi, is this on? Yeah. So when you submit your DNA to these companies, what are the privacy settings with it? Are they allowed to sell it? Are they allowed to give it away? What do you agree to when you sign up to do one of these tests? What's the deal with it?
So we've got privacy settings. Yeah.
A few years ago, I was at my dentist and I had to have a dental implant. And I was saying, are you going to make the implant the same as the previous tooth, which has got a step in it towards the top of the tooth? And he said, oh, well, that's interesting. That means that your teeth are directly descended from Neanderthals. I don't know whether people, a lot of it, if you feel the inside of one of your molars and it's got a step in it, apparently that is direct descendant from Neanderthal. I'm wondering whether that would show up on the DNA testing.
Okay, so we've got privacy settings. We've got, was his dentist talking nonsense?
Yeah, so you said the current mutation rate was about 70 to 80 base pairs per 3 billion. I was just wondering, is that number changing at all with, say, atomic testing, with people spending more time in the sun, with all kind of, pollutants in the atmosphere?
Privacy, teeth, mutation rate. Privacy.
Okay, so, well, anything that you do in life, I would always suggest that you read the terms and conditions to try and understand what you're signing yourself up for, although one of the problems is that it takes a long time to read terms and conditions. One of my friends did actually do a YouTube video of himself reading the ancestry terms and conditions. It took him 40 minutes to record the video. But we are, in Europe, we are controlled by, we have something called GDPR, General Data Protection Regulation, and all the companies have to comply with that. And that essentially gives us control over our data. And all the companies, all the big companies have made sure that their websites are GDPR compliant. And that one of the key parts of GDPR is that you control the data. You have to give your consent for your data to be used. So your data is not sold to pharmaceutical companies. You, at 23andMe, you can, if you want, opt in to have your data shared so that it can be used by pharmaceutical companies for drug development. And that's something that I choose to do, as do 80% of other 23andMe customers. And I just, it's my choice, but it is for the greater good, and they actually feed back the data to me, and I've got a page there which tells me that my data has contributed to 80 scientific research papers. But it's an individual choice as to how much you share and what you want to share. And with the matching, you can opt into matching. If you get a surprise match with someone you weren't expecting, you can opt out immediately. But you cannot take away what, once you've started to share your data, something is always going to be out there. So it's a question of just deciding how much you want to share in advance.
And one thing that is worth pointing out is that you're unlikely to leak DNA data, whereas all of us are leaking data all the time from the thing in our pocket. So kind of wet biological data, i.e. your DNA, you're not going to give it up unwittingly, which we are doing all the time with
well,
where
actually,
we move.
You are shedding DNA
well,
all the time.
So. Teeth. Is he...
Is this question about Neanderthal DNA? Well, so... Certainly all, like I said, all non-African ancestry carries with it a small percentage of Neanderthal ancestry, and we're talking about 2 or 3% perhaps. And that's distributed in fragments all across your genome. Now, that's not very much. Some people have suggested or attempted to identify some correlations between these particular Neanderthal bits of DNA and an effect on certain characteristics. It's quite hard to do that. I'm not convinced personally that it's been done very plausibly, although I might be forgetting one or two studies. In essence, I'm going to say that we probably don't know this, that this particular a particular shape on your tooth, a step, is associated or caused by Neanderthal ancestry. I'm guessing that maybe this is a feature that Neanderthals have, but even that wouldn't be sufficient to establish that that this was caused by the Neanderthal DNA that we actually have. It's probably unlikely, is what I'm going to say. But it's not implausible a priori that the ancestry that we do have plays some role, maybe in a very minor way, in some traits, maybe in some parts of the world. That's not impossible.
And then, I don't know whether you planted him in the audience, but he asked about your current interest, which is mutation rate.
That's right. So there is this question. So it's remarkable, actually, how little we still know about the mutation rate. We've now got a pretty good idea about what its average value is in humans today, because we now have sequenced so many parents where we can directly compare, families where we can directly compare the child with the parents and literally count up all the places where they're different. I've made that sound very easy, and it's actually extremely hard. But anyway, that's essentially what's being done. Now, the question is there evidence that it might have changed? It probably has changed in sort of recent human evolution. We certainly know it's changed over a longer time scale, because when you look at other species, they have different mutation rates. And it seems on that time scale to have slowed down in humans. So we have fewer mutations per generation, say, than our cousins, the chimpanzees, or other primates. But the nub of your question then was, now that there's all this kind of, is there greater exposure to things like atomic radiation or sunlight or things like this? I'm not sure if that's true, that there has been, but even if there were, the mutation rate, remember, that we're talking about is the one on the germline, so that's got to affect. In other words, the cells that are kind of deep inside you,
sperm or eggs,
if depending on your male or female, sperm or eggs. So things like getting sunburnt probably aren't going to affect that. It's certainly quite likely that you could get locally increased mutation rate from if you lived, near a nuclear accident, but I don't think globally that's an effect that has any significance. But we do see evidence that there has been some very small changes, perhaps due to environment, we don't know the cause, in different parts of the world.
Right, let's take another 3 questions. So, go.
So just to pick up on the previous question about privacy and consent. So while there might be quite tight controls that you personally sign up to whenever you send your DNA off for testing, are you not also, though, in effect giving permission for your parents or your siblings or your half-siblings and the share of DNA that you share with them to be used in a way that they might not themselves agree with or want?
So we've got Privacy 2.0, the gent behind.
Yeah, I wonder if I could make a comment and a question, if that's all right. My comment about the big data.
I don't know. Merge them into a short one.
Big data, very quick, get out and vote and make sure you have the government you want. The question, though, is are you guys living at a sweet spot in history where you've got the technology to map all the DNA everywhere in the world, but people recently were fairly stable and stationary, didn't move around very much? In the next few hundred years, won't we all stirred up and it'll be much harder for you to dig information out?
Love it, thank you. Okay, and we've got 2 more here. So we've got, just so that you're cogitating, Privacy 2.0, mobility.
I spoke to the professor of genetics in Tokyo, who told me that they are not allowed to touch any material from the emperor's palace on the basis that the emperor represents the purity of Japanese race, and they didn't want to see any Korean genes in there. How is the English royal family protected?
Love it. Okay, so the super posh and their heritage, and we'll take one more. Speed.
If you could get everyone in the world somehow to be tested, all their DNA tested, would you, and why?
Oh, nice. Omni profile. Okay, so family.
Right, so that's actually a very interesting question because, as you rightly say, we share DNA with our parents, with our cousins, with our siblings, but I think the right for an individual to take a DNA test has now become very well established. What we still haven't determined are the boundaries of, what happens when we're sharing data. So that's particularly the case with these criminal investigations. So it may be that you're happy to upload your data to GEBmatch, but it may be that your sibling is not happy to have their DNA tested and would not be very happy for you to have your DNA on GEBmatch. But your decision affects them just as much as it affects you. So that's why I think that with all of these issues, it's like a sort of group consent. We need to get to a level where we as a society are happy with a certain level of sharing with the actions of law enforcement agencies or governments or whatever to do what we think is best with our data. And it's really a conversation we need to have, a debate we need to have at the society level. It can't just be decided by a single person.
And Debbie,
or by
we were
family.
mentioning just before that one's feelings about this change depending on whether you live in a free healthcare society or in a pay-for one. So obviously in the US, if your sibling being sequenced showed up something about your health that would then change your insurance premiums, you'd have a very different set of emotions around it to the way that you or I might think, well, fine, I'm still going to be able to get healthcare at the point of need. Okay, so mobility and you, and as a researcher. So, Aylwyn, 50 years hence.
You might be kind of cursing the fact that now everybody is sort of we're all mixed up. Actually, I'm going to say that although that you could imagine that will make certain kinds of analysis more tricky. For example, the one I said about finding people whose all four grandparents were from the same place, that maybe those individuals will be less common. But on the plus side, I'm fairly confident that we will have much more ancient DNA and also historical DNA. And so actually I expect and perhaps even extend the limit back beyond 150 to 100,000 years or more. So I actually think we probably will know more about the past and about things and the sort of human history and prehistory on a genetic basis for that reason.
I mean, one way in which researchers like you are fretting about the future is today's techniques for extracting ancient DNA can be quite destructive. And there are people calling for, think of your ancestors on a research, think of your descendants in the research lab of 2050, because if you grind it all up and ruin it today, it's not going to be there for them when the techniques are even better in the future. Okay, so tracing the ancestry of our monarchs and emperors. What do you think, Debbie?
Well, this is a case where that person does not have to be in a database in order to infer their ancestry. You can infer their ancestry by testing their direct male line descendants to get their Y chromosome, or you can trace the mitochondrial DNA line to get to it would have to be a sibling if it was a male ancestor. And depending on how far back it is, you could also use autosomal DNA.
We could just pinch their hairbrush.
Yeah.
So the Diana's butler of 5 years hence might just be slipping a bit of a hair
in the UK,
23andMe.
if you test someone's DNA without their consent, that is actually a criminal offence, and you could be put in jail for 2 years. But it's not a criminal offence in America and in most other countries.
Wow. So if you could have everybody sequence today, what would you do with it? Aylwyn and then Debbie?
Well, that would be great if it was all done in the way that that I think in a way which perhaps is very different from how it's been done so far. And I think one of the issues. There are parts of the world which are kind of approaching this, actually, we should say before that. So we are possibly going to arrive there sooner than we think. But there will nevertheless be parts of the world that lag far behind in terms of their access to and the way that they're able to use these new technologies. And one of the problems I think that we have to face up to in genetics, and particularly in human evolutionary genetics, is that there is less. There's a very dark past, particularly in anthropology and anthropological genetics, to how some of the early studies were approached, and I'm going back decades here, and the legacy of that is still with us, and how indigenous communities around the world were treated and how their data was treated and used. So we have to overcome that now, and that's a big mountain to climb in some parts of the world. So I think that will be a big obstacle to us actually being able to achieve this, and to be able to do science and to do genetics in a way which benefits everybody and engages everybody who should be and who wants to be.
I mean, one upside of if it were possible,
yeah,
is that the bias of all of our databases towards the white Northern European male aged between 20 and 50 would be wiped out by everything else.
Yes, there are huge potential advantages and benefits to doing this. So I do think that we will eventually end up somewhere close to this. But it's just that there are caveats.
Yeah, there's a load of ifs. Okay, so Debbie, would you if you could, and what would you see if you did?
Well, in fact, some people have actually proposed this as a solution to the problem of the fact that we're all, if we test 700,000 markers as we do with one of these commercial tests, all you need is about 1 million people from one population for everyone to be identified by their third cousin. So for forensic purposes, some people have argued that it actually makes more sense to test the whole population at a low resolution, doing a standard forensic test, which only covers 17 to 20 markers. And those types of tests don't actually reveal any personal information. They don't tell you anything about your ancestry, anything about your health. So if you then have results from everyone for an entire population, it will help to solve crimes much more easily, and it will actually not be so invasive on people's privacy, because at the moment what the researchers are doing, they're having to trawl through people's genealogical records, they're having to go through Facebook accounts, often looking at quite personal information. So it's not so much the DNA information that is very revealing, but it's all the other associated information that's needed for identification. So to me it would actually make good sense to have everyone in the population certainly in a forensic database if it was properly controlled. And probably that's something that only in certain countries you would actually have that trust in your, in your government to do that.
Mm-hmm. You touched in on the fact that world was coming sooner than we thought. What were you referring to?
In the sense that these technological developments are becoming, sequencing technologies are becoming much cheaper and much more widely available, and I think within the next sort of decade we're going to see things that people can buy really quite cheaply as sort of home kits. But I think one issue is that how we manage the sort of ownership or the control of this data is going to be maybe increasingly a problem. I mean, already, there are probably around 1 million whole genome sequences that have been carried out for various reasons all around the world. But those are not available to most researchers just straightforwardly. You have to be a member of the particular consortium, you have to get access, you have to explain what you want to do. So, there's various kind of boards that control all the different ones. Now that might seem, you set up all of this access, which is all sensible. But the downside of that is that also adds a bias which is harder for, say, researchers in the developing world to get over, to get access to these things. And we can end up actually increasing disparity around the world. We might reach a point where we do have people sequenced all around the world, but only really Western wealthy scientific institutions are actually making use of the data and publishing it. Mm-hmm. So we definitely want to avoid that. We didn't really say what I would do with it, and really there's so many things I could think of doing it. Nearly every single thing I do, every single bit of research that I and everybody in my field works on, for example, involves one of these large data sets now. There was a data set collected about 10 years ago called the 1,000 Genomes data set, which is still now one of the only sort of freely available and publicly accessible collections of genome sequence data on that scale that you can use. So there's been a lot more sequence collected, but that's the only one that you can use widely, and it has had a huge impact on research in this field. So a larger data set from Africa around the rest of the world would be
And as Debbie touched on, each time you tip in a new load of data, everything changes. So
lots of findings.
You tip in Iceland, And then, oh, look, we understand height a bit better than we used to. You tip in, well, hopefully sub-Saharan Africa.
Absolutely, loads of things about the genome we only really are discovering because once you get to the level of having tens or hundreds of thousands of individuals, in some cases things will be quite rare. You'll need to have sequenced maybe 1 million people to start detecting that effect on a significant level. So that's really, there are lots of discoveries to be made from this really large-scale sequencing.
Marvellous. We have got 9 minutes, so let's take another 3-ish, 4-ish questions.
So you mentioned earlier the problem if the government get their hands on people's DNA. Surely if you've done nothing wrong, you have nothing to fear. So what is the problem with this?
Okay, done nothing wrong, nothing to fear. Yeah.
So we're talking about this, like a lot of people just generally are doing these tests. How is education in the general population kind of keeping up with these tests happening? So in schools and with people, just education, I guess.
Okay, so we've got nothing to fear, education. Yep.
Hi, Living DNA thinks that I'm 13% from South Asia, and I've had a good look at all of my relatives. I can't see any trace of a sort of Asian look about them, but my grandparents, my great-grandparents were in India out with a lot of their relatives as part of the British Raj. So I'm wondering if my hypothesis is that they left some of their DNA behind, shall we say, and that they currently assess me as being part Indian because there are many of my relatives who've left DNA in India in recent times. Is that a plausible interpretation of an unpublished methodology?
Okay, so that's kind of cousin stuff. And then up in the gallery? The gallery's going to have to be some kind of
Hello.
Fight it out, because I can't see. Yeah.
As you already mentioned, like for current home DNA testing, different companies use slightly different methodology and like different data, and they return kind of like different results to their customers. And as you can expect, it's also same for the test on the disease risk. So overall, there are biases in different companies' analysis outcomes. So and as you know, like for public, they wouldn't have knowledge and ability to judge the quality.
Okay, great. So we've got a couple of questions there on the quality of what you're getting back. So I think you could take together the one about how much cousins, for example, a few generations back, and then maybe we could answer the disease risk biases and differences in what you get back. You could answer those together, Debbie.
Okay, so if you've got 13% Asian DNA, that's usually an indication that you probably have an ancestor, perhaps at the great-grandparent level, who has some sort of Asian ancestry. It could be a combination of two more distant ancestors. If it's a very small percentage, like sort of 1 or 2%, we can usually ignore that. But that is probably a signal of an ancestor from British India. But with the DNA tests, they provide a clue, and then you have to go back to the genealogical records to try and see if you can identify the ancestor who made that contribution.
There is a caveat, which is that it depends to some extent on the particular database that this company uses, and it may be very unrepresentative or small for South Asia. Maybe it is dominated by people with a mixture of European and Indian ancestry, and that might also skew their result in that case. There's a number of different ways that such a result could arise, and in fact, I would expect that something to do with their database is perhaps more likely if it really is unknown, and if you do know all of your recent ancestors. But then again, people do quite often get surprises. So.
And so I think we can then connect that to methodology and bias and good signals and bad around disease risk. So similarly, it would just depend on what's in there, how good the corpus is, how good the...
Yeah, again, I think Debbie was probably a better...
Yes, I just wanted to add one other thing, that it would also be a good idea to transfer your data to some of the other companies to see if that same signal is reproduced elsewhere. If you get the same signal in other companies, then it's much more likely. So you can do a free transfer to MyHeritage and Family Tree DNA with your living DNA data. But for the health reports... I will have first-hand experience when I get my revised 23andMe reports. So one interesting thing when I looked at my Alzheimer results, I'm supposed to have a C and a T at this particular position. So the first thing I did was to look at the raw data for both of my parents to see which one had the C. And they've both tested at Ancestry DNA. I opened up the results and they both have 2 T's at those positions. So somewhere, something is wrong in those results. So I'm interested to see if it's going to be replicated at 23andMe. But I mean, one of the reasons is that they're all looking at different papers, and it depends on when they update the research they're basing their reports on. So just curating the research is actually a big job in itself.
And I think what you've said leads really neatly onto the education question, because what's becoming clear is that to navigate all of this information needs a level of being kind of comfortable with quite a lot of information. So do you feel that there needs to be a bigger education piece around personal DNA testing and around DNA and what it means in general? I think that was the question. Is there a kind of education gap?
Well, I think definitely, but I mean, the problem extends not just to the general public, but if you had a health report and you took it to your doctor or genetic counsellor, they are probably not going to be able to answer the question very well either, because there is not very good DNA education in the medical profession. But I think actually taking a DNA test and being able to explore your own results and to test lots of other family members and to see which bits of DNA you've inherited from each ancestor actually helps with that education process. So I think it's something I'd like to see more and more people doing, because I think the more people understand how DNA works, the better it will be for everyone.
So the kids of tomorrow, rather than extracting an onion at the DNA in their science lesson, they'll be doing kind of cheek swabs and going, oh, brilliant. I'm part Neanderthal and I'm probably going to cark it from Parkinson's.
Well, I mean, I think that there is a lot of people there is definitely a lot of misconception about, how DNA works, how your genome works, how important, how likely it is, how likely you are to get certain diseases or something, or if you have a certain variants of your DNA. I think people have a sort of a folk sense of both how DNA operates and how it's inherited, which is really quite different from the truth, and it would be great if that was part of, I think, school education. I certainly never learned any of this at school, and maybe that would be the thing to do, is that we all need to learn a lot more about our genomes at an earlier stage.
And have a far better sense of how the past few hundred years fits with the past few 100,000 years, and then maybe we'd all feel that actually we're part of a bigger global family.
Yes, indeed.
And it might help with not just a sense of who am I closely related to, but that we're all
so things like
this
concept of pure ancestry from a particular region or anything like that, which is a total nonsense. That would be very easily dispelled with a relatively small amount, I think, of education at the right point.
So we had the if you've got nothing to fear, you've got nothing to hide question, which kind of takes us back to a bit of a dark place after one global happy family. I mean, I do just want to tip in here that anywhere that there is a database, there's going to be baked in bias, and it is incumbent upon us to remember that the policing databases in the US are hugely skewed by historical bias. So the people that were being arrested in previous years and previous decades are massively overrepresented. So if you, those databases are absolutely chock full of African American DNA. And those biases get reified if you take decisions using them. So similarly, there are postcodes to which Amazon will not deliver in the US owing to baked-in historical bias. So me personally, I disagree with you've got nothing to hide, you've got nothing to fear, because our databases are not fair. I don't know if you want to add to that.
Well, I mean, I think this is a much bigger question about all kinds of data. Again, it's not specific to genetic data. Data about you as an individual, you could be concerned about for reasons that aren't necessarily to do with having committed a crime. There are legitimate reasons for wanting to have certain things about you being private, which are not illegal or not necessarily something that you've got. You might fear. You might have done things that you want to keep private that aren't necessarily against the law. And I think that there is a sense in which privacy is a culturally variable thing, and we might have an expectation now in the Western world of more privacy, particularly in the sort of this particular era, the late 20th century, early 21st century. We might expect more privacy now than previous generations did, who were often living in smaller communities. But I don't know that that necessarily that was a good thing for them. I think that there were lots of oppressive aspects of society back, if you go very far back in time, when people knew everything about everything that was going on. So I'm not sure that I like the idea that we lose that.
And Debbie, what's your take?
Yes, I'm the same as you. Even though you may think you have nothing to hide, nothing to fear, people can make mistakes. And you're now, as with advances in, say, DNA technology, scientists are able to extract DNA from smaller and smaller samples. So there's something called transfer DNA. So I could be sitting here tonight and touching something. Someone else could come along and touch the same thing. That person could then go off and commit a murder, and my DNA would be found at the murder scene, even though I wasn't at the I was nowhere near the crime scene. So you can still be implicated in things even if you weren't there. And mix-ups can occur in labs. So there have been cases where samples have been mixed up or contaminated. And there's a project in America called the Innocence Project, where they're now using DNA to exonerate people. There are people who've been in prison for 20 or 30 years or more for crimes they haven't committed. So I think we need to encourage better education, better interpretation of all types of evidence to make sure that those mistakes don't occur again.
Marvellous. Well, I hope this really fascinating evening with two such informed and passionate experts has been a great step towards that greater education around navigating the world of personal DNA data. So all that remains to do is to thank you enormously for a fascinating evening. Thank you.